Oh, why hello, children. Today we're going on an incredible adventure. Today, we're going to venture into the wonderful and magical world of randomness. Many things in this world will not make sense initially. Many times it's because I'm trying to make a point. Or other times it's because I bet someone that I would put something in a video. You know who you are. We live under the assumption that our world is governed by the laws of cause and effect. However, on a day-to-day basis, we often forget this assumption. That was like the randomest thing ever. When we say things like this, we don't mean that the event was actually random. We just mean that we don't understand it. This is not a pipe. See what I mean? Sometimes the things we classify as random are things we don't have all the information about. But other times, the information is there, and we just don't see it. But enough about that. Let's talk about Belgian artists. My favorite Belgian artist is René Magritte.
And my favorite of all his paintings is this one. You see the inscription? Ceci n'est pas une pipe. That means this is not a pipe.
The truth is that was no more pipe than this is.
This is a collection of hundreds, maybe thousands of pixels, each portraying a unique and specific amount of red, green, and blue light so that your brain interprets the image as a pipe.
Just as Magritte's pipe was no more than a bunch of paint on a canvas.
When someone asked Magritte about its inscription,
He replied, "If you don't believe me, try filling it with tobacco."
oh snap!
When the main ideas behind this is that we have a tendency to view things holistically. No one looking at this video is thinking about all the individual pixels that comprise it. Well, now you are, because, I mentioned it, but, you weren't earlier thinking about it. So what does any of this have to do with randomness? Well, the less we know about something and how it works, the more we perceive its actions to be random.
Para ejemplo, this is Johnny. Johnny's been working on his PC all day, trying to wrap up on his physics project. Suddenly, something goes horribly wrong! The next day, Johnny tells his friends about how his computer randomly gave him the blue screen of death. But Johnny is viewing his computer holistically, and not thinking about the many, many levels that lie beneath the operating system.
What happened to Johnny is somewhere along the way, something went wrong. It happens. But Johnny, who's only viewing the computer at the topmost level, holistically, views the blue screen that he got as a totally random event. Okay, so that's what randomness isn't. But then what is randomness? In theory, something that is truly random wouldn't follow any laws of logic or cause and effect or predictability whatsoever. Whether something like this actually exists in our universe is currently unknown. But nerdy Adam, that's not true. Oh, hey cool Adam. What do you mean that's not true? Well, there are plenty of legitimately random things in our universe. No, there actually aren't. What about coin flips? A coin flip isn't actually truly random. If it was, something like this might happen. But it's still random between the two options that are open to it, heads and tails. Even that's not true. The result of a coin flip is the effect of a cause. Only there are many causes, and their influence on the result are very subtle. But I'll get into that more later. What about the random function of my calculator? That's actually just a pretty complicated algorithm that is designed to make it look like it's spewing out random numbers, but it's actually not. Here's the algorithm. And actually, slot machines work in a very similar way. Oh, that was my next one. How about the movement of tiny particles like electrons? That may be legitimate. Arguably one of the most important debates of our time is whether things on the quantum level are truly random or not. All scientists can agree, though, that if truly random things do exist, they would be incredibly small. Okay, but if truly random events can only happen on the quantum level, then why are many things in our world highly unpredictable, such as the movement of the weather, or this lava lamp? Good question. But before we get into that, let's just stare at this lava lamp for a while. Okay. Alright, so now we're really starting to get to the crux of this topic. Chaos theory. Chaos theory really got its start in the 1960s with the most famous meteorologist ever. Say it with me, guys. Edward Lorenz. Why didn't you say it with me? Lorenz has been painstakingly recreated here.
Lorenz created a computer model that would replicate the basic actions of a weather system, with varying temperatures at different places in the simulation. The model was a big success, accurately simulating a real weather system. A few months after creating the model, Eddie decided to test out his system some more. He paused the program and printed out all the data for that time. He got a lot of temperatures and placed those temperatures into the same program running on a different computer. Then he unpaused the first simulation. After letting the programs run a while, Eddie printed graphs of the temperature at a certain point in the two simulations. He expected the two graphs to be the same, but instead he got this.
But how is this possible? The two programs did the exact same thing to the exact same numbers at the exact same time, but they got different results. That's like 2 plus 2 suddenly equaling 33, or a giant T-Rex suddenly smashing up Lorenz's lab. So this is how it happened. When Eddie printed off the data from the first simulation, he told it to round off after 3 digits after the decimal point. So that means that the data was off by, at most, 0.0005 degrees. But after only a month of simulated time, that small difference turned the two systems into totally different entities. And thus was born chaos theory. According to Chaos by James Gleick, chaos theory is centered around the principle that events have a sensitive dependence on their initial conditions. This is more commonly known as the butterfly effect. Now, for those of you who didn't see the movie, the basic principle is that if a butterfly flaps its wings in Brazil, the minuscule amount of air that it moves can eventually snowball until it becomes a tornado in Texas. Thus, over time, a tiny factor can have major consequences. Consider the classic example of Schrödinger's cat. Yes, it is pronounced Schrödinger. My cat has been locked in a room with a small bit of radioactive material. Since the decay of radioactive materials is based on the movement of small particles that some consider to be truly random or at the very least highly unpredictable, one of two actions can occur. I'm coming, Professor Whiskers! I'm coming! Oh my god. Oh my god. He's okay, everybody. He's okay. Oh, Professor Whiskers. I'm coming, Professor Whiskers! Professor Whiskers!